Hey guys, so let's discuss about something special, that is a native VLAN. What is a native VLAN? First, you understand. So in previous section, we understand about the tagging method. So we know that we having a two switches, and if we want to pass the multiple VLANs, you must have to tag them so that you can identify which frame is belong to which VLAN, which data is going to belong to which VLAN, right? So it must be tagged with .1q, which is 802.1q, or might be the ISL. But what if I don't want to tag this VLAN with these two protocols? So if I am going to send untagged VLAN informations, let's suppose I have the some VLAN 10, 20, or 1, and I don't want to tag them. I just want to send directly untagged to the another switch. In that case, this is known as native VLAN, right? Means there is no any kind of the trunking protocol tagging available. So these are the default VLAN. These are the native VLANs. So why we use a native VLAN? Why there is no trunking is there? So in IEEE 802.1q trunking protocol, we know that the tag is going to be added, but in native VLAN there is no tag, right? So it basically used for the management purpose. Let's suppose I have the multiple switches, right? And I just want to make one of the VLAN as a native VLAN. That means it is going to propagate across all the switches, and it is going to understand by all the switches without any kind of the discrimination. You don't have to identify the frame and all. So when I have the requirement to just uh, manage the network on the basis of the native VLAN, then I can use for the native VLAN. By default, in every switches, the VLAN 1 is going to be native VLAN. By default, on every switches, VLAN 1 is going to be native VLAN. Let me show you something in the lab so you guys can understand. Let me see. What I'll do, I'll make the trunk port between these two switches. So show interface trunk. So there is no trunk. So what I'll do, I'll configure the trunk. Basically, these all concept is going to be used for the only for when you're going to do the trunking protocol. Show interface trunk. So this is not trunk, right? So if I'm just going to make the two port as a trunk, which port? F is 0 by 0 and 0 by 1. So I'll go here and I'll go in the configuration interface range. I'll go and define fast Ethernet 0 by 1 to 2, and I'll just put the switch port. Let me put switch port mode trunk. This port is going to become a trunk. And if I just enable the encapsulation also, I want to make this trunking as a .1q, that is open standard encapsulation. This is not going to support it by default, so let it be. So just make the trunk. The trunking protocol is not supporting. I'll go another switch also, and if I run the interface range, and this range is fast Ethernet to 2, and I'll run the command switch port mode trunk. Now if I'm going to run a command show interface trunk, so let me see. Let me see here what is happening. Show IP interface brief. So ports are showing up and up, right? And why they are not in trunk? Because the port channel is not in trunk. So let me configure this also port channel as a trunk, because we configure this two port as a trunk port. So this port channel also need to be trunk. Let me switch port mode trunk. So now this is, let me see, you can see this is the non-trunk port. It start giving some warning. So let me see, once I have some access. Hey, what happened? Just need to wait. Show interface trunk. You can see there is a trunk, but now you can see this VLAN is showing VLAN1 is a native VLAN. You can see why? Because we not make VLAN1 as a tag. By default it is going to be native VLAN. So let me show you something else. So I'll configure here also show IP interface brief, and if I'm going here configuration T, and let me make this port channel also as a trunk, interface port channel switch port mode trunk. I'll just make it the show interface. If you run the command, you can see here now we are running the which protocol encapsulation. We are running 802, right? Status trunking, but we just have the one VLAN, that is a native VLAN. It is a native VLAN. Now if I'm going to create the multiple VLAN, so let me create the few more VLAN, right? So I'll just go on the switch here and create VLAN 2, VLAN 3, or let me create 10, 20 and 30. So VLAN 10 I created, VLAN 20 I created, VLAN 30 I created, VLAN 40 I created. So if you show here show VLAN brief, these 4 VLAN also created, right? You can see. And if I go and create these VLAN also on the switch 12, because VLAN database you have to create. Right now you can see so VLAN brief you run, then you can't find this VLAN on this switch. So I'll go here in the configuration VLAN 10, I'll just create VLAN 20, I'll just create 30, I'll just create 40, and I'll create the VLAN 50 as well. So if I go and run show VLAN brief, you can see this VLAN has been created. So now if I'm going to run a command show interface trunk, so you can see these VLAN is going to be processed, right? But they are not showing the native VLAN, means they having the special tagging, right? They have the special tagging, but especially this VLAN is showing as a native VLAN. Why? Because by default this VLAN is going to be native VLAN. So if you even do the packet capture in the 𝗪𝗧, I cannot show you right now, but it is going to show in this way. My VLAN is going to be native VLAN, and this is going to be my complete always as a native VLAN. But I want to make another VLAN 10 as a native VLAN. So right now it is going to tagged with the special trunking protocol. So if I want to create, let me go on the interface port channel 4, and if I go and run the command switch port trunk native VLAN 10. So I'm just making one of the VLAN as a native VLAN. So now if I'm going to run show VLAN brief, so show interface trunk, so you can see right now it is not showing as a native VLAN, but let me configure another side also. So I'll go show IP interface brief. Oh sorry, I configured the wrong port channel. Port channel should be 3, not 4. So this should be the one region. Let me configure correctly on this switch first. Interface, and I'll configure the switch port trunk native VLAN 10. Okay, so if I run the command, see here show interface trunk, now you can see now we have the 10 as a native VLAN, right? Earlier it was 1 by default, but I make as a 10. So let me go here and configuration again, and let me add this command. So at a time one VLAN can be native VLAN. So let me try to, I cannot add multiple VLAN. So 10 if I am going to add, so now it's going to give the mismatch. So let me correct here also show IP interface brief. So at a time one VLAN can be the show no interface port channel 4 interface port 3. Mistaken, we created port channel 3, and I run the command switch port trunk native VLAN 10. So by doing this, if you run the command show interface trunk, you'll see I have the native VLAN 10. So by default native VLAN is 1, but if you want to configure the native VLAN, it can be configured. Just you have to follow the same command on the interface level, then it is going to be configured. So how we can summarize the native VLAN concept is the internal component, like you can just understand it's the part of the IEEE VLAN tagging method where the frame is not going to be tagged with any special VLAN identifier. Means it is always at a time one VLAN going to be native VLAN on the switch. By default it is a one VLAN, right? So untagged frame is going to be processed, means the frame from the native VLAN are transmitted untagged across the trunk links. Whatever the trunk links we have between the switches, all the trunk links, like this is a one trunk link or might be a multiple trunk link, they are going to carry the VLANs as a untagged. This means when the frame enter into trunk port, right, and it's belong to the native VLAN, doesn't have the VLAN tag added to it, means the, let's suppose one frame is going to be processed for the VLAN 10 or 1 which just created. Once it is going to enter in the trunk port, it is not going to add any special tag, right? And even it is going to exit from the trunk port and entering to the switch, it again going to be part of the native VLAN, because this switch also know which is my native VLAN, and I'm going to just give that information to that particular VLAN because that is a untagged. Default behavior we understand, VLAN 1 is always going to be native VLAN. This is the default behavior. However, it is a considered a security based practice. Change the default native VLAN if you have the real network. So never leave the default VLAN as a native VLAN 1, and you can change it by the different VLAN ID, or you can remove that, right? So this is how it is going to be like configure the native VLAN. And native VLAN benefits, if you go in why we use the native VLAN. So if I'm going here and just search why we use native VLAN, so you'll find the multiple article. Main concept is to just manage the network. So the genuine VLAN will encapsulated with the frames, means any VLANs which are actual genuine VLAN, they are going to be encapsulated either ISL or .1Q, but the native VLAN operates as a legitimate VLAN with on members. Transmitting the frame are encapsulated or tagged, right? The key benefits, right, if you find like just for the management purpose it is going to be used. So if you go and find some community guidelines, so you'll get some kind of the, he is talking about, I know that native VLAN is configured on trunk port links which does not add the VLAN ID, the frame going to be coming from the native VLAN, also known as the use for the, this is like what is the, then finally he is answering his question, right? So he is trying to answer, let us answer the first part, right? As you know, the switch has two type ports, trunk port and access port. We know that trunk port carry the multiple VLANs, access port going to carry the single VLAN. On the access port switch, expected traffic receive untagged. Definitely, access port never tag the any traffic, right? Since the end points does not understand the VLAN concept, like the end point is the computers, servers, they not understand. Switches only understand the tagging information because they're having that capabilities. While trunk ports are expected through the, as I said, track traffic. So when you untag the traffic is received on the access port, switch would simply associate the traffic from the port with the VLAN configure on the port. As a trunk port, traffic should be tagged definitely, and the switch use the VLAN information to decide which VLAN the traffic belong to. Simple definition. By the tagging, it come to know from which VLAN this traffic is coming, and then it is going to process the data. And this leads to us native VLAN concept. In the switch, to receive the untagged traffic on the trunk port, what will be the switch will basically do with, right? So to switch, basically VLAN is associated with the here the native VLAN concept used for the second. Why device has no VLAN support? So you can see there, this is talking about a lot of topology and native VLAN going to be used. So you can see native VLAN was created when the hub were still being used, and you normally have two switches connected. So other hub So he is just explaining some kind of the scenario where hub is connected and all. So in short, you can understand in this way. If I'm going to use a native VLAN, basically the traffic is going to be untagged, and this basically used for the management purpose in the real network, right? So that's all about the native VLAN. I hope you understand about it. Already we discussed about the trunk code and all. So this two concept is very important. Azure two concept and native VLAN, right? Let's continue to the next session. For time being, we can stop it here. Thank you.